Good afternoon, ladies and gentlemen. I'm so glad that you're all here today. Let me welcome you to the second in our spring lecture series. Our guest speaker today is a very distinguished architectural and structural engineer, Mr. Nat Oppenheimer of Silman Associates in New York City. Before I give Mr. Oppenheimer a proper introduction, I'd just like to remind you that we have 2 more lectures scheduled for this semester. Both of them will be after spring break, but they will be coming in rapid succession on Monday, March 30th, and on Monday, April 6th. So please mark your calendars. It gives me great pleasure to introduce today's speaker. Mr. Oppenheimer is a native New Yorker, and he is a graduate of Clarkson University, which is in far, far upstate New York, in Potsdam, New York, where he received a Bachelor of Science degree in civil engineering. When he finished his degree at Clarkson, Mr. Oppenheimer has told me that he had a choice. He could either become a restaurant chef or a structural engineer.
Cook, not chef.
Yes. Pardon me, I want to give you a promotion.
Yeah.
Yes. Well, he made his choice, and here he is today. Yes. Mr. Oppenheimer has been working for the past 32 years, primarily with the same firm, Robert Silman and Associates Structural Engineers, which now has 4 offices in New York, Boston, Washington, D.C., and just recently, Ann Arbor, Michigan. There was a brief period in the 1990s when he had his own firm of Friedman and Oppenheimer, but he has spent all that time since then with the distinguished firm of Robert Silman Associates, where he is now executive vice president and senior principal. Mr. Oppenheimer is a registered and licensed engineer in 19 states. He is a LEED accredited professional, and he is also a visiting faculty member at many schools of architecture. He is a regular lecturer at the School of Architecture at Princeton University and a visiting lecturer at the School of Architecture at Rice University in Houston. He is very active in professional organizations. I'd only like to mention 2 of them. He is on the board of directors of the Salvadori Center, a nonprofit organization that uses the built environment as a monumental tool, a motivational tool to teach math and science to at-risk inner city students. He is also the treasurer of the Architectural League of New York. I would like to ask you to join me in welcoming to the podium of our auditorium, Mr. Nat Oppenheimer.
Thank you. Thank you. Yes. Thank you very much. Thank you, Dr. Rabins. It was great to be able to spend a little time with some of you in the studio today. Hopefully some of this, I think it will resonate with you and the work that you're doing. It's great to be here. It is something that I don't do often. I'm primarily a practicing engineer. And I want to ask your forgiveness up front. I am going to read portions of this lecture only because I do want to try to develop a sort of general thesis here and not lose track having fun just talking to the slides all the time. So, as I said, I will admit that when Professor McCoy first reached out last fall for me to come out here, I was I was flattered and slightly confused. I'm first and foremost a practitioner, mostly in the Northeast. And while I do teach 1 day a week, I primarily spend my time trying to figure out how to get aspirational designs built and working closely with other engineers and architects. But I very much appreciate, given the amount of time I spend practicing, I very much appreciate these opportunities that such an invitation affords me to step back, reflect a bit, and consider what it is we're up to and what it is we're trying to do. And it's especially good to do that when times are good. And you happen to have caught me at a very nice moment. Our firm is fortunate enough to be involved in a number of wonderful, groundbreaking projects, many of which I'll show you here. And I've been asked to participate in a symposium in April that will explore how structures are taught to architectural students And Silman, as a firm, will be given the Collaborative Achievement Award at this year's AIA National Convention in LA this coming May. So, having been granted this award for collaboration and asked to opine on the role of structures in one's educational journey, it must mean that I'm simply here to tell you how to collaborate and that you could just get on with it. I can certainly tell you to listen well and respect others on the team, as many of you expressed to me today in the studio, that great success only comes through hard work or through failure and more hard work, and that no one can do it alone. And while that's all true, it is only the most obvious prerequisite to all the rest. All the rest is what we are currently poking at, interrogating, and challenging, and what I hope to do today. After 32 years of doing this, and I know to many of you that makes me really old, I have a good sense of what successful collaboration looks like and methods for facilitating good collaboration. But I certainly do not feel I am done learning, and tonight is intended to be more of a prompt than a lecture. So please don't take notes. And there's a video anyway, so it doesn't really matter. Why do that and not simply show you a bunch of slick graphics of stress diagrams that demonstrate the firm's mastery of engineering? Because the development of all these stress diagrams and nice outcomes is truly reliant on our ability to constantly evolve our collaborative skills. To evolve, we must be aware, and to be aware, we must be present, which means I must be present today, at this moment, in this place, and not away in some mountaintop shouting down at you the various rules of collaboration. I will show a few slick images because it's fun to do that, and I know it's nice to see. And it does bring me joy to celebrate successful collaborations once in a while, and this is a nice occasion to do so. But let's get back to the word collaboration, especially within the field of architecture. It is, in fact, written on the very first line of your school's mission. And while I don't want to take anything away from your school's mission, I would venture to bet that almost every architecture school in the United States and beyond has collaboration somewhere in their mission. At this point, the idea of architects collaborating is pure cliche. As you will hear and see, I am all in on collaboration, but not as a static tenet, unchallenged and assumed. And my main question to start tonight is, has it always been thus? As I was preparing this lecture, I got to thinking about the history of collaboration and chatting over a number of wines with my wife, who's an architect of X number of years, which I will not go into, prompted a discussion about the idea of collaboration and the history of collaboration in architecture. The idea we hold to be a basic truism of the profession represents so very little of the basic iconic architecture that we see around us. Considering the following brief walk through the history of architecture and collaboration therein. On the far, your left, Brunelleschi's dome, developed by a single person and a lot of labor, and maybe a few other people, but generally Brunelleschi, well before the math to reference, no structural formulae to deal with, and no engineers to hand a sketch off and ask how big the chain around the base should be. Palladio, with his palazzi and villas, all amazingly beautiful, with nary a structural or mechanical engineer in sight, and basic graphic statics and an understanding of prescriptive methods at his hands, and that's it. And by the way, in the New York City Building Code to this day are not the rules for palazzi, but are prescriptive methods for designing townhouses where an architect can go into the code and build a townhouse and sign and seal the townhouse based on rules given by the code that were first written in the 1800s. So this tradition lives on. So then you get to the third slide. 1638, 200 years after Brunelleschi, Galileo, the father of essentially all of science, ventures into structural engineering, and among us structural engineering nerds, completely blows it. He posits that the stress-strain curve is pure stress or pure strain, and that the piece of wood in the wall will simply pull directly out of the wall when it fails rather than rotating about its neutral axis. It takes 150 years for Navier to come along and point out that Galileo was wrong. He had to wait till Galileo was dead and so on, but he did point out he was wrong. And he essentially bursts the modern structural design movement 350 years after Brunelleschi builds his dome. We head into the 19th century to the Crystal Palace, and Joseph Paxton develops this building based on experimenting with flowers and lilies, according to the, of course, always truthful Wikipedia. It is said that he floats his daughter on a bunch of lily pads to figure out how strong they are, and he builds the Crystal Palace. Bessemer comes along in 1858 and invents carbon steel. But nobody cares about carbon steel until the Chicago fires and William LaBarangeni's home insurance building. Still, not an engineer in sight. William LaBarangeni graduates a year before or a year after Eiffel from the L'École in Paris, and basically goes it alone as architect, engineer, and builder of the home insurance building. And then the birth of modernism. And the entire idea of modernism around technology, minimalism, or efficiency, let's say, and materials. And yet even the modern masters really embraced, and it was unfortunately the great man theory. The modern masters went it alone for the most part, with very little reference to collaboration within the earliest masterpieces of modernism. And in fact, the story is that Auguste Commandant, who is the structural engineer for most of Louis Kahn's work, boycotted the opening of the Kimball Art Museum out of distaste and anger at Kahn for dismissing his contribution to Kahn's work. So there was not the collaborative spirit that you see these days. Utzon famously wars with Peter Rice and Ove Arup throughout the entire design and construction of the Sydney Opera House, developing what is clearly one of the most iconic and beautiful buildings in the world, but has nothing to do with the shell structures of Candela, Nervi, or Torroja. There is more reinforcing and concrete in the base of the Sydney Opera House than you'd find in almost any concrete structure around. So we are not quite at collaboration. What I would put forth to you, and I can be corrected, we can all play this parlor game. Feel free to correct me. This is a very quick survey. What I would put forward to you is that it is really not until the Pompidou Center, and it's not because I've been fortunate enough to work with Renzo Piano. I do think the Pompidou Center was one of the first projects that showcased, while there may have been collaboration on previous projects, the Pompidou Center was all about the collaboration between Piano, Rogers, and Peter Rice at Ove Arup. So this is sort of the dawning in the early 70s of the idea that team can build a machine. And they developed the Pompidou Center. I'm not sure too removed in my mind as I thought about it coming into campus today from putting a man on the moon and many other advances at that time. So the idea that a large team could get together and get equal credit and urge each other along comes into focus. But think about where we are. We're 50 years back from today, and I started 500 years ago. So we're talking about 10% of the built environment around us, essentially, not by volume, but by years. Although a lot of those structures lasted quite a long time. Mario Salvadori, a mentor of mine, comes into focus. He actually taught for years at Columbia, but he publishes Why Buildings Stand Up, and essentially changes the entire pedagogy of how structures is taught in architecture, where he really speaks eloquently and beautifully about the language that we speak between each other. And I want to keep an eye on that word language. All right, that is, to me, the key to everything that we discussed today. Mario spoke of this language in a talk he gave in 1958 about teaching structures in architecture school, his early ruminations that ultimately birthed, as I said, a whole generation of collaborators. And I want to quote him here from that talk in 1958, quote, "And as soon as I say that we engineers are most eager to collaborate with you, I mention the first great difficulty. Architects and engineers do not have a common language. If you go to the average engineer and tell him," and he used only male pronouns, I apologize, "and tell him that you," on behalf of Mario, "tell him that you want to design space, he laughs in your face. If you tell him that you are looking for beauty, he tells you the only thing that matters is economy." We've come a long way since then. Through Salvadori, Rice, Piano, Rogers, and all the rest, we have learned to communicate. Engineers, at least the ones who work on the projects that drive advances in their profession, no longer laugh in the architect's face when they ask for help in designing space or beauty. But this is a tiny fraction of the story. Communication is different than language, and I want to talk about language. What is the difference between communication and language? Communication can happen through a UN translator. As the engineer, you understand the basic design proposition is important, and as an architect, you know that it's important that the building meet code requirements, not collapse, and be comfortable to occupy. I would suggest that most of the industry these days communicate with respect, but still without a common or consistent language. The engineer may know that it is important to the architect that the buildings stand up on only 3 legs, and they know it is important to celebrate that fact if they want to get the project. But they often do not challenge why it is important. And challenging in a common language with common goals, combined with respect and trust, built over multiple collaborations, is what ultimately breeds amazing success. Sharing a language gives the architect a chance to interrogate their why and the engineer to ultimately understand why. And so this evening, as I walk through examples of some of the projects I've been fortunate enough to be part of, I will work to give you a sense of the language unique to the projects or relationships. What patois added spirit or soul to the endeavor? I will pause on occasion to reflect on lessons learned along the way, small mental constructs that have helped me put different moments of a project in context, helped guide me back to the proper language for that moment of struggle, or help frame a discussion for a new team member who may not be fully up to speed on each dialect or accent. So the first mental construct, never ignore the most basic obligation the engineer has to the project. No matter how inspiring a project may be, we do have a grounded, fundamental responsibility. Our primary goal is to keep the left-hand curve, the stress in the structural element, generated from external loads, far enough away from the right-hand curve, the material strength, so as to be safe, but close enough so as to not be uneconomical. Piece of cake. It is a piece of cake once we get there, but 99% of what I show you tonight was accomplished well before we got to that point. I say this simply to note that one of the hallmarks of the collaborative revolution of the last 50 years is the invitation for us, the engineer, to join the conversation well before the bell curves are in play. So then, where to start? Let's start with the language of love, shall we? So these are a number of examples of temporary heart projects that we were fortunate enough to work on. There is a competition every year at Foley Square in Times Square for a 2 to 3 week installation of a heart on Valentine's Day, including Moorhead and Moorhead's wonderful ice heart that melted away exactly almost to the point of the 3 weeks they were commissioned to build the sculpture. In this case, the business of interrogating collaboration is to understand the balance we bring to every collaboration. The installation is temporary. Therefore, we get to play with that left side of the curve a little bit and the loads applied to the heart. And the ownership of the vision firmly in the designer's hand. This is not a collaboration where we are upping each other's game to get to a new design paradigm. There is a design that we have to make sure it doesn't fall down. This language is one that often allows for mock-ups, in situ load testing, and the like. Designers have an image, they build it in their studio, and then we just push and pull on it rather than try to run models or basic formulae. This was especially true with the Big Bamboo installation on the roof of the Metropolitan Museum 6 years ago. Big Bamboo is an installation designed by Doug and Mike Stern, who are well-known artists. There's an incredible video on YouTube from about 10 years ago, I think, or 8 years ago, you could see, where they literally walked this sculpture across their studio in the course of a year and filmed it in stop-motion photography, where they basically took bamboo sticks every day, took them off the back end and added them to the front end, and walked the sculpture about 300 feet like in a massive slinky across their studio. So they were commissioned to put up a massive version on the roof of the Met, and we were asked to prove that it would not fall down or collapse under the weight of visitors walking on the walkway in a public space in one of the most open spaces in New York City. We could not model this. You do not put this in SAP or RISA. The bags you see there are our version of load testing. We knew that this thing was not going anywhere. That's actually the first thought we had. So all we had to do was validate and prove that, and our collaboration with the Stern brothers was simply that they allow us to put some sandbags on the walkway and that we could look at the overall dimensions of this thing and get a general sense that it wouldn't blow over in the wind, which we then signed a letter to the building department, and all was good, and it didn't fall over. The last sculpture I want to show you is Maya Lin's bell tower in Shantou, China. Again, the image was there. Maya knew exactly what she wanted to do. I've been fortunate enough to collaborate with Maya Lin for the last 25 years. Maya Lin knows very much what she wants. You do not tell Maya Lin that it has to be bigger or shorter or wider than what she drew. The tower is 80 feet tall by 2 feet wide. It's in a high seismic zone. It's unoccupied. So the biggest design collaboration portion of this project was essentially detailing the stone wall so that the excessive deflections would not crack the stone throughout and that the gaps in the joints would not be too big as to seem unsightly or veneer-like. But that was the extent. The other part of it was convincing the local officials and engineers that we were not insane, which we eventually did. They made us sign many letters, which we did. It stands to this day. The biggest challenge turned out to be that they were worried the bell would ring in high winds, but that was not our responsibility. So I want to now build a little bit to the next size projects. Before diving into full buildings, I want to go through a couple of small examples of projects where the collaboration was more about getting unique structures built. They weren't sculptural, they were architectural in a simple definition that they were there to solve problems that existed, and there was a client and somebody paying for this, and there was a desire to do something a little different. So the collaboration on these jobs, this is a wonderful canopy installed at the University of Wyoming by Louis Suramaki Lewis, LTL Architects in New York City. I've taught for 20 years with Paul Lewis, so we have a very close collaboration on these projects. And the basic idea was, how can we do this in a way that's detailed and designed that we can get local builders who are really busy and have no interest in doing something different to be interested because we're using very, very common techniques to build something unique and different. So the entire discussion around this collaboration was simply detailing the job in a way that allowed local subcontractors, again, they're not worse or better, I'm not making any judgment at all, they just have a lot of work. And why do this necessarily when you can do acres of the work you always do? So it was trying to figure out with LTL how to design details that mimic those other things they did, facades and so on, so that they saw this as another job that they would do with a slightly different skin that was delivered to them, and nothing else would be different. We set all the columns at a certain elevation so that as they laid this canopy out, the work they were doing was no different than the work they would have done elsewhere, resulted in a unique proposition. Similarly, the kayak storage shed at Long Dock Beacon that we worked on with ARO. As I was mentioning to one of your professors during the tour of the studios, the interesting thing in New York, when I talk about collaboration, is that everyone knows everyone and everyone's related in some way. And Paul Lewis, one of the Lewises of Louis Suramaki Lewis, is married to Kim Yao, the partner at ARO, and they all get invited to the same competitions. So I show these two back to back as also the relationships that evolve way beyond collaboration. This project, which has been published quite a bit and we're incredibly proud of, built for almost no money. What you don't see is a series of very simple galvanized beams above, 8-inch wide flanges, totally common construction technique done by a local ironworker, a miscellaneous metal shop. I think they do motorcycle repair on the side. And galvanized metal deck, composite metal deck, just hung from the bottom of the beam rather than placed on top. The storage shacks provided lateral bracing, So we had wire cross-bracing across the basic off-the-shelf storage racks, allowing for 2 incredibly thin columns up front that did no work in terms of lateral. Building again further, but in a very unique collaborative spirit, is the work we've done over the last 20 years with Gluck Plus. Gluck Plus is a firm that came out of the firm Peter Gluck and Partners, now has 4 younger partners, younger, all in their 50s. Peter's son Tom, and 3 others who I've worked with now for 20 years. This is Tom Gluck's house, built on a shoestring. But the beauty of Peter Gluck's office and of Gluck Plus is that this is a firm that for 40 years has done true design build. The architects in the office draw the drawings, they design the beams, we check a lot of them. These days their work is getting more and more ambitious, so we're doing more of the actual design. But then the architects go out and build the building. This is not about design build where the architects do it and form a joint venture with a contractor. The architect who drew the details is out in the field getting yelled at by the subcontractors about how the details don't work. They spend 2 or 3 years in the field. They come back and they draw the next building, more knowledgeable about how these houses go together. It is an incredibly wonderful collaboration. The language we speak with them, we have to stop them almost from being too conservative because of all the yelling they've gotten over the year in the field. So Tom knew he wanted to build this house for himself and his wife and 2 kids. He wanted it to be different. His father had bought a piece of land that he built his own house on 20 years before. He was able to afford this basic steel frame, but the rest of the house is all in simple plywood shear wall for lateral support, and then the upper portion is all various cost-effective, I'll say, not cheap, skins and so on that allow the house to rise up into the treetops with all the lateral being supplied by shear walls, plywood shear walls at the base. It did move a little bit until we put the windows in, which with a paying client that wasn't the actual architect, we probably would have not played with, but since we knew Tom wouldn't sue us, at least not yet, we were good to go. This built into a number of projects with them, which I'll rifle through very quickly, but again, it isn't just small follies. This project in Austin, Texas, we ended up with a pretty massive truss, and again, a very close study. We probably studied 20 or 30 different truss profiles to get the windows in the rooms where they wanted, but an efficient truss that the house could afford. And it allowed for this sort of seminal moment in the house, again, a house that's pretty widely visited in Austin. And finally, out of about 30 projects we've been fortunate enough to do with Gluck Plus, is a recent wonderful project in the Bronx. This is a public tennis facility that was built about 2 or 3 years ago. Gluck Plus, because of the work they do and the way they do it, was able to build this facility for about 1/3 what all the other competitors said they could build it for. Mainly because the way Gluck Plus works is they go out, they take packages unlike any other firm we work with. They go out and they bid out packages in piecemeal way that they control. So they go out and they bid the foundations before any of the rest of the structure is done. They get feedback, they understand where the price points are, they tweak the design to fit to the best price for the sub without losing all the design. Then they send out the steel separately because they're not getting yelled at by a CM or GC to keep the process flowing. They control it. And we're able to play with forms and ideas with them in a safe space that doesn't necessarily exist when you're trying to speak the language with a client paying a huge amount of money and a school or an institution that wants very firm answers along the way. So the final project, again, for an underserved community and a public tennis facility, well beyond a lot of private facilities in New York. I want to now, that safe space, that idea of playing with folks like Gluck Plus and others where we can really go out on a limb. So our firm has done a huge amount of private residential work over the years. And people are like, why are you doing houses? Houses have budgets often, not Tom Gluck's, but many, that afford you the ability to go way out on a limb. You get to do a lot of R&D on houses where the owner is paying $2,500 a square foot for, or where the architect's actually building the building. And we take these things and fold them into bigger high-profile jobs. So on the Campbell Sports Center at the northern tip of Manhattan with Stephen Hull, and this is one of Stephen's iconic watercolors that they basically show us at the beginning of the job and say, collaborate. We knew that there was a moment in the back of the facility with these columns and this idea of a kink column. Having done this on houses and with Gluck Plus, we knew exactly what it would take to do so, and we worked for a course of about 3 months with Stephen in his office to develop, this is 6 out of probably 70 different tilting schemes where we basically registered in a roundabout way with their office multiple generations of tilted column design until we came to a place where Stephen's aesthetic values were pleased and the economics of the tilt made sense. That there was enough static equilibrium that we weren't, putting huge amounts of concrete in the ground to hold it up and not a huge amount of steel up above. This project ended up being concrete precast plank on a steel frame and came in at about $400 to $450 a square foot. For those of you who know this project and know buildings like this, that's a fairly incredible feat to take basic materials and turn them into something unique. So, another brief pause as we move out to projects more controlled by the design team, into a series of more complex projects where the ability to hold on to most basic design intentions without constant compromise is challenged on a daily basis. In these projects, where there are often 10, 20, or 30 consultants all vying for the architect's attention, what is the best for the project is not often clear, and in many cases simply conflicts. You know this. Mechanical or acoustical systems that would benefit from mass in a super light structure, fire ratings that push back against structurally viable mass timber, which, by the way, perform a lot better in fire than steel, but fire departments around the country haven't quite caught on to that. Maybe a completely open facade begging for a shear wall. Not only does the ability to speak the language take on more urgency, but the ability to think one step ahead in that language and to finish each other's sentences becomes more critical, at least to creating joy and success. Louis Kahn and Auguste Commandant created amazing buildings together, but it appears Kahn felt threatened by Commandant, and while successful collaboration ensued, it's a shame that they could not celebrate their success together. I know that sounds romantic, that there is less value to a team of rivals than a team of amigos. I fully recognize that both can work, but I do believe, based on experience, that one can challenge and be direct and criticize and not end up not speaking to each other or boycotting. And I do feel that long term, the best comes out of ultimately appreciating each other's role in the process and building from collaboration to collaboration. And what better trope to call on, which I have before in other lectures, I apologize, but it's too good to pass up, in terms of sticking together even when emotions run high, than my old friends, Mick and Keith. It's a trope I have leaned on before, and it is one that I cannot get out of my head, ever, 25 years after first hearing it. The genius of Keith Richards, it has been documented, and this is an actual quote from a musical history book, is his ability to play a microsecond behind Charlie Watts, the drummer, showing my age again. And it is this talent that makes the Rolling Stones, as a 53-year-old, the greatest rock and roll band ever. The structural engineer, I would posit, must figure out a way to ensure that as a collaborator, we support the architect without falling too far behind or getting too far ahead. With this construct in mind, I often see my role that microsecond behind, propelling the design forward without displacing the effectiveness of the design partee. What does a long-term working relationship look like? How do you spend so much time speaking unique languages with specific teams that you can naturally fall right into a magical pocket behind the driving beat? It humbles me a great deal to show the following series of images and a small portion of our work with Stephen Hull and Renzo Piano Building Workshop in an effort to show how these through lines can elevate language over a series of successful projects, and still lead to unique solutions. So I'm going to rifle through these a bit to give you a sense of these collaborations. Again, the watercolor that starts every Stephen Hull project. This is VCU, the new art museum, opened about 2 years ago at Virginia Commonwealth University. Again, similar to Campbell Sports Center, the interrogation of the monumental curved wall at the entry to the museum. As Chris McVoy, Stephen's partner, who I've worked with now for 25 years, We'll tell anyone that listens, and we'll sit there with the model with every subcontractor. The curve is a ruled surface. He'll take his credit card and constantly wipe it down the surface to make sure the subcontractors understand it's really a piece of cake and nothing to worry about. We studied every different variation on this: concrete shells, light gauge metal, steel frame, ultimately settling on a design build scheme with Zahner, the facade manufacturer, on an integrated facade approach that used tubes and lighter structural shapes to back up the Zahner facade. But the project itself, like many we've done with Stephen, was an amalgam of multiple design schemes. So for those of you who are studying singular design attempts at each project, know that there's a world out there where you could have a steel facade with precast plank, post-tension concrete, concrete slabs, and massive steel transfer plate girders and the interior of the building. These are all the precast plank and poured concrete elements, the steel sticks, the foundation, and the bearing concrete walls of this project. In construction, this was a series of boxes that come out appearing to float. What you don't see are the large cantilevered beams coming off of this mass, meeting other cantilevered beams on this mass, singular hidden columns within the formulation, and the facade at the entry ultimately being realized on what is now one of the most highlighted corners in Richmond, Virginia. Again, done for a client with tremendous aspirations at ultimately a very tight budget. The next project is one that recently completed, opened last spring. We're incredibly proud of the new, what they're calling the Reach, which is the new addition at the Kennedy Center. Stephen Holt won a competition about 3 years ago for this, or 4 years ago. What Stephen will say, it is the largest green roof in the country, 70,000 square feet of occupied space under the landscape, all designed to basically house major rehearsal spaces and the majority of parking coming off Rock Creek Parkway. Also included in the job was a very shallow bridge that features a mass damper in its base to limit vibration given the shallowness of the depth, to both allow for head height over Rock Creek Park and a height restriction coming across the parkway. So these buildings were idealized originally as a white marble to match the original Kennedy Center. Value engineering turned into exposed concrete. A unique aspect of this project was that it was not a museum. So in museums where we're constantly fighting exposed structures in the Northeast and the inability to celebrate any sort of exposed structure, we were left with a concrete wall poured in place, exposed on both the interior and exterior, and large open volumes inside. Oop, hold on, I'm going to skip for a second. Oh no, I took out that slide, I apologize. And now, that's embarrassing. Trust me, there's amazing images online of large volumes in the middle of the space, in this space, allowing the air to stratify and the conditions of condensation and so on mitigated, where in any other museum building, the idea of an exposed concrete wall in the Northeast would be anathema. Many of the features of the project were after years of experimenting on smaller residential projects and gallery spaces with Stephen's office, including these crinkled concrete walls, formwork that was placed within the form, so this is the actual concrete poured, and the reinforcing behind this formwork, very conventional. Among the other challenges on the job were this 60-foot tall curved wall whose formwork had to be custom designed, and pressures at the base exceeding any that we could handle with formwork, so lifts had to be poured at about 3 feet at a time in order to build this entire wall the whole way up. One lift hardening after the other going up through the wall. We looked at shotcrete, we looked at self-consolidated concrete, we looked at ultra-high performing concrete. We ended up with sort of the down and dirty cast-in-place concrete, however, done in a very controlled manner with a variety of lifts. And finally, the sawtooth in the performance space. If you go into the main performing space within the Kennedy Center, the Reach, is this sawtooth form, which is not only sawtooth form, it is post-tension 70-foot span with most of the action for the structure happening at the valley of the Sawtooth. This is the space before it was painted blue with the crinkled concrete walls. There it is, blue above. It's fairly dramatic. And again, we mixed on this project post-tensioning, void form concrete, so there's Kobiak's bubbles all throughout this project. For those of you who have looked at Kobiak's bubbles, or the fiberglass balls that they put in concrete slabs now to allow for a thicker slab and less weight, mixed with post-tensioning, and mixed with a number of steel structures, including the bridge. Finally, with Stephen Hull's office, a project that's just about to open, the Arts Museum at Franklin and Marshall. This project brought us back to earth, but again, it's that collaboration where we knew what Stephen was trying to achieve. We've worked with him enough that at this point we can sort of look at the watercolor and understand what's going on. So this was the original. It's for Franklin and Marshall, Benjamin Franklin's namesake school. The idea of the kite, even Stephen can be fairly literal in his architecture at times. And how do we achieve that again, like Campbell Sports Center, in an incredibly cost-effective, or shall I say aggressively budgeted project? This one ended up being primarily a steel structure with trusses used throughout the project to cantilever off a concrete base of cores that follow all the walls inside, and a simple, quote-unquote, sort of umbrella structure around the perimeter of bent steel beams to form the outside edge, with rolled tubes forming the purlins across and the roof down the side. Oops. Sorry. Getting ahead of myself again. This shows the tubes that fill out the roof and the idea of the form when it's finished. The roof has recently gone on, hopefully opening and published soon. But again, even having accomplished the work we did at the Kennedy Center and post-tensioning and void form and all these things, it was joyous for us to sit down and return to a project with Chris and Stephen's team and many of the same people from VCU and from the Reach, and just try to figure out a nice, simple partie for this building that we knew didn't have the budget or time frame that we would have on the others. And with Renzo's office, we've been fortunate enough to again up the ante further and work on many high-profile projects, including the Whitney Museum in downtown Manhattan. The key to the Whitney being that the entire lateral system of the building essentially is housed in the north 2/5 of the building. The southern 3/5, for those of you who have been to the Whitney, are massive column-free gallery spaces. Now, when you look at the frames, this is what exists within all the offices of the Whitney Museum. The only lateral piece out on the southern edge are the two brace frames you see in the glass wall of the bookstore, acting somewhat like a spring over here, not taking 3/5 of the load, but basically just stabilizing the southern facade, which above this is purely solid facade, housing a lit gallery. These, again, using, of course, being Renzo Piano, the two cross braces that are seen, highly articulated, custom cast con fixtures at the connections and so on. You will note the beautifully symmetric X bracing, and you will know as an engineer probably that the actual beam is about 6 feet above where this cross brace meets, putting a lot of local bending on the column. Still, it looks quite lovely in the window. Part of the challenge of the Whitney was, again, the procession. With Renzo, the language is less about the overall image, the massing, the watercolors, the realization of these ideas. With Renzo, it is about machines and getting to the sense of order. And in a way, that makes our job really easy and really difficult. On the Whitney Museum, it was a 20-foot grid. Anything you did on that job was on a 20-foot grid. If I had a question, I went to some multiple of 20 or some division of 20. And the columns in the lobby being no different, although they change in height as you go east along the length of the building until you get to a 50-foot tall single column at the outside of the building, holding up this entire end of the building. This is, that yellow dot, the only structural element that I've ever designed that caused me to drunk text an architect one day when I saw the column erected, and I texted Renzo's partner and said we shouldn't have given in, because we had designed a completely cantilevered building at this end, and we saved $1 million by putting that column in. And to this day, I wish we had fought for that $1 million, but it's not my $1 million, so I don't get to say that. The studies, again, knowing that the language of the repetition, the modularity, the rhythm was there, we then had to just figure out how to address that. Now, we knew, working with Renzo, that this was not, we could not put massive moment frame columns in there that were covered with fire troll covering. Renzo doesn't do fire trolls. So we knew that these had to be true columns, intumescent painted. They had to be related in some way. And the blue dots are solid 15-inch columns. The red rings, hollow 15-inch diameter, where the load allowed hollow versus where solid was needed. All 15-inch diameter. We sourced a 22-inch solid steel column, but the schedule didn't work out, so we went with a concrete filled, which is a real shame. This being my drunk texting column here on the outer edge, and this the procession columns as you go up the Whitney with the High Line right here, for those of you who have not visited the Whitney. Renzo, again, constantly looking for truth in the structure, although I did tell you about those cross braces, and it is being videotaped, so I'll have to edit prior to sending. I want to get this number right, sorry. 1,000 kips of load, 1 million pounds coming down this main building column, and meeting what is not artifice on the Whitney, but a true canted base plate. I was telling somebody I did a lecture about a year ago on this, and I forgot we had put a massive shear lug in there. And I did this entire lecture looking at those bolts, confidently standing up in front of a group of people saying, 1 million pounds, no problem, and thinking in my head, I got to get back to the office and make sure this is okay. There is a large shear lug in there. You can sort of see it dashed in there. The next project, again, rhythms. Language with Renzo Piano's office, the Fogg Museum, the historic Fogg Museum in Harvard, with the addition that Renzo designed that opened about 5 years ago. The key element, other than the galleries in this space and the reworking of the existing building done spectacularly beautifully, I think, was the lantern. That essentially won Renzo the project. And the idea was a massive, as Renzo's known to do, machine-like skylight at the top that included shading devices and all sorts of mechanisms and evocative of the work at Pompidou Center throughout his career. We knew, having worked with Renzo's office, that the idea of intumescent paint on these steel elements was anathema. For those of you, intumescent paint is fireproof paint. Seems to be the get out of jail free card for many architects when they don't want to put spray on fireproofing. It is goopy. It looks horrible. It is not exposed steel. It's just really goopy paint. So we knew part of our job was to try to figure out a way to get the building department to buy that this was not a roof. It was instead just a sort of big skylight. And so our approach from the beginning was to design a truss around the ring of the building, right of the historic parapet, that acted both as a brace for the parapet and the building and a support for the skylight, so that we could prove to the Cambridge Building Department that this building would be safe with the collapse of the skylight. Ultimately, they bought that justification. I don't say that like they bought it. They agreed with that justification. And the design of the lantern and what you see when you look up from the entry piazza is all exposed steel roof structure, well within what would normally be a fire restrictive zone. One of the interesting parts of this project is that Corbusier's ramp that he designed for the Carpenter Center next door comes onto our site. The original proposal was to cut the ramp off right here at a joint that existed, store it for 2 years, and bring it back. The architecture school freaked out about that, said we were not allowed to do that, and convinced the president of Harvard to convince us, and then Harvard board members, to spend an extra $3 to $4 million to suspend the bridge 40 feet over the excavation while we dug a pit 30 feet into water and built the entire building back up to a plaza where we quietly resettled the ramp back on top of the roof that was 3 stories of occupied space below. So sometimes the collaboration is with another group of architects in another part of campus. Finally, with Piano's Office is a project recently opened about a year ago in Des Moines, Iowa, the Krause Gateway Center, otherwise known as the headquarters of Come and Go, the large, do they have Come and Go's in Oklahoma? Yes. One of the largest chains, I think it's the largest convenience chain in the Midwest, or so they told me. There's a great picture I have of Renzo Piano wearing a bright red Come and Go t-shirt at the first kickoff meeting. We knew in this project that the idea we had to carry out were these massive cantilevers of the building, this cantilever being about 36 feet, or this one's 24, this one's 36, 18, and 12. And we knew that based on schedule, we wanted to get them in and doing the offices, completing the offices, well ahead of putting the entire brim on the hat. Because we also knew, working with Piano's Office, that there would be a lot of discussion about the materials that went around this brim. So we spent a lot of time detailing and designing that cantilever, this being the outer edge of the cantilever, this cantilevered beam connected to the building structure at the glass line in a way that allows us to macro adjust for level at the back end and then micro adjust the edge so that the line is perfect at the very end. These elements went on the building probably 9 months to a year after the main carcass of the building was complete and much of the interior work going on, including the facade on the building. We had to store the facade, we had to store pavers and so on outside on the edge of the raw steel before putting these materials on to allow us to put the facade in so that when the materials went on, the deflection didn't harm the facade. So many of these projects, the facade detailing is so tiny that you have to pre-deflect the structure so that any loads that go on the building after, other than live load, any dead loads that go on after the installation of the glass, your steel does not move. So this is construction photos of that cantilever, and you see this entire sort of infrastructure built out prior to finishing that allowed multiple moments of adjustment and essentially 6 months of tuning the building prior to final cladding. So a final pause before the next series of photos and a quick diversion to bring us back to reality of everything I talk about here. There's a desire for absolute inspirational objects, and yet there's often a checkbook, and that checkbook's attached to a bank account, and that bank account most of the time is attached to a finite number of funds. I've often pointed out to frustrated team members when we're beaten down in a value engineering phase or our sanity questioned as we present our new 120-foot cantilevered balcony that most every client wants a Monet, and yet they want it for the price and schedule certainty of a refrigerator. That is our lot in life. That's reality. Ignore this reality through your career at your own peril. Given this reality, it becomes even more critical that we speak the same language as the architect and the other team members so that our prompt solutions, suggestions, and idea drive the design forward to unique solutions while at the same time respecting the constraints of the project. There's a great, wonderful myth that tension between the architect and engineer will generate better projects. I don't believe that. Where successful, our collaboration is not a parrying back and forth in place. It is an advancing of aspiration to a built reality. I would simply ask, as you look at the next series of buildings and examples, to keep that in mind. Communication without a common language can stagnate, and discourse with a language often advances. So the project I want to show now is Grace Farms in New Canaan, Connecticut by Sana. We did collaborate early on with this project with Dr. Sasaki in Japan, who is Sana's longtime collaborator, amazing engineer, and I give him full credit for validating a lot of the ideas that we sort of worked through and giving us support. He did not have to do that. He was very generous with his support and what he offered to the client as confidence in the design that we were working on. Grace Farms, for those of you who don't know it, is this incredible facility. I recommend all of you take a pilgrimage there at one point. It is a foundation that supports the arts, nature, it now has started a massive movement to eradicate human slavery from the built environment, of which I'm part of. And it is partly a sanctuary for a privately funded church that holds services there on Saturday. It is more than anything the foundation, though, I've learned over the years. So we knew early on, and we had not worked with Sana, but remarkably, we had worked with every other member of the team, including the contractor and the client representative. So we had a good sense of what we all were after. We could band together and sort of understand what we were after. But we knew early on this was as close to a napkin sketch as I've come, and I'm sort of undermining my underlying theory by suggesting that I need a long-term relationship. Sometimes it does just come to you. There was this idea of meandering the river going down the hill, and there were these columns throughout the entire project supporting a continuous roof. We knew, looking at it, that there was nowhere on this job that Sana would allow a moment frame or a cross brace. This was not a language where I was going to sit down at the first meeting and say, it's a really lovely diagram you have there, but we're going to have to throw a couple of moment frames in there. So from day one, the entire partie was, and this is the meandering river the whole way down with 5 pavilions enclosed by glass, but the roof is continuous. This is the sanctuary, the library, the dining hall, the tea room, and the basketball court. This is basically the early partie. That's the columns, 168 columns. So from day one, we knew this entire project had 4 components and 4 components only. And the only way we were going to get this built was to be able to constantly hammer away at the refinement of the most basic story of these 4 components. The first were the columns. Every single column designed as a single flagpole cantilevered from its foundation. Not a single moment frame or cross brace anywhere on this job. So there is the only lateral system on this job are the flagpoles. At the pavilions, they're connected by a curved 10-inch by 10-inch steel beam, same size on every pavilion, same size in every location, sized for the worst span between columns in one of the pavilions and the worst load, and then just fabricated in Ohio, shipped to New Canaan, and erected on top of the columns to establish the shape of each pavilion. Digitally designed, sent off to the shop in a Rhino model, comes back nice and curved and over each column. The columns in this case, as we went about documenting the project, there's a column schedule that I don't show here. 168 columns, X, Y, and Z coordinate at the bottom, X, Y, and Z coordinate at the top. That's it. Cut this many columns and move on. The only time that I will get on Dr. Sasaki, we designed 4.5-inch solid columns. Those were value engineered to 6 5/8 steel tubes. We toured the building with Dr. Sasaki a year after it opened, and Dr. Sasaki looked around with the owner, who I got to know very well, I know very well now, and said, in Japan, we would have done smaller columns. And the owner looked at me and said, why didn't we do smaller columns? And I did not say to her at the moment, because we value engineered to larger columns. Owners don't like to be reminded of that sort of thing. The cantilever of the roof, achieved in some cases with steel flitch beam design within this glue lam. The third element being the glue lams that span between the rings. We looked at all different combinations. We could have done different size glue lams. We could have taken the same glue lam and spaced them closer together. We had a little bit of a problem. We had 2 pavilions that were over 45 foot long. If we designed the same size glue lam for the worst case, it was a glue lam that almost couldn't get down the curved roads of New Canaan. So we worked with Sana. We came up with a singular size of glue lam that we used on the entire project all the way down the river. I think it's 28 by 18, somewhere in that range. And at the pavilion and at the sanctuary and at the gym, we simply turned those glue lams into the top chord of a king post truss. We went to Sana early on and we showed an arch structure, we showed a cable structure, we showed them all sorts of things, and they did not want a beautiful flat river that ended up with a little like the snake that swallowed the mouse at the end, so they voted very much for the truss idea. Working with Dr. Sasaki's assurance to Sana that we knew what we were doing, we created, at that point in Sana projects, what you can get away with a decent budget, some incredibly beautiful details that allowed You see the end of the glue lam, which is the identical detail to the glue lams throughout the project at the edge of the 10 by 10, with the tension rod coming into a curved end, which is nailed in, or split ring fastened into the end of the glue lam, and a washer to hold the tension back as a chalk block at the end of the truss, just like old-fashioned bridge trusses of the 1800s. This is the plan view of those details as they were built, and the finished view of the gym building. In the gym, the spans were a length that we went with a single post, in the sanctuary, a double post. The gym being sunken below ground, I haven't even spoken about the cantilever retaining walls that made up the gym and some of the fun we had down in the basement. The finished space is quite unique, and the client has been incredibly supportive of both Silman and the project and our work there, which is always a nice outcome as well. So my final images this evening speak to the future of collaboration and the optimism I have for the future. If I've learned anything along the way, it's that Mario's words from 1958 were prophetic, or perhaps obvious. This is a group culture, and yet it is really, really difficult to get a building built with a large team. As technology advances, the ability for all team members to simultaneously inhabit the same model, invent and advance is upon us. Trust me, it's upon us. Which means that the need for each team member to be concise in their thinking and for the language between us to be clear is critical. Often these exchanges can get confusing, messy, and fragmented. Over the past few years, however, I found solace in return to the most basic fundamentals of structural engineering within the universe of big data, which of course harkens back to your own mission statement. Building a model and designing a beam or column is now, after 20 years or so of software development, fairly bulletproof. It is rare for a senior engineer on a project to review every beam calculation or frame analysis. And the time you are given to do so, frankly, is not conducive to member-by-member check. Does that mean we rely on the computer and assume it's right? Far from it. The bulletproof nature of elemental analysis has pushed us to better understand expected overall behavior, global load paths, and broader metrics to reality check the models. And more importantly, as we get better and better at seeing the fundamental components of a project, we ensure that we control this model and that the model does not control us. What does this look like in practice? We are now at the obvious stage where we can round trip almost simultaneously and instantaneously from Rhino to Revit to SAP and back again. Within these round trips, however, we as a firm have added a key 60,000-foot reality check step that continuously brings us back to our initial design partie, or at least challenges the design partie, if it no longer is appropriate. Our understanding of how we expect the structure to behave and how it is behaving in the model, the load paths and the overall reactions at the boundary conditions, and the overall weight of the structure, which used to be done simply to track the cost of the structure, and it still is, but it's also a good measure, obviously, of our commitment to sustainability. Our language is now wonderfully, it seems, almost full circle to the basic fundamentals of structural engineering. After 60 years or so of intense calculation and the fetishizing of quantitative analysis and parametric modeling and all the rest, we seem to have temporarily arrived at a moment where that is finally automated. So rather than close up shop, we choose to engage even deeper, to speak the graphic and diagrammatic language that architects too seem to have chosen. Project we worked on, it's now on hold, the Berggruen Institute in LA, up on an amazing ridge, unbelievably cleared of all foliage in the fires last fall, unfortunately, but I guess they're a step closer to demolition. This is by Herzog and Demeron. It is a ring project about 350 feet by 150 feet, held up on very few columns on the ridge of this high seismic zone with a massive auditorium dome and a water tower, which we also want to use as a damper for seismic shaking. This was essentially done through concept design over the course of 8 weeks with Herzog Demeron, where we basically round-tripped through Rhino models and were able to give them studies in precast concrete, post-tension concrete, cast-in-place concrete, steel design, and CLT and NLT, nailed laminated timber, all within the course of 8 weeks, producing ultimately a matrix of quantities and pros and cons that allowed them ultimately to get to a precast series of elements brought together by post-tension strands. Unfortunately, held up in schematic design due to various permitting and so on, not on our doing. Hoping to get back on track soon. The other project I want to show, which is a confidential project that we're in the midst of right now, is what I referred to obliquely at the beginning of an architect asking you to hold a building up on 3 legs. This is a project that we are now in the middle of, almost done with 50% CDs, and we are working where this is a 25,000 square foot platform, 60 feet in the air, hanging a 14,000 square foot interior viewing platform about 45 feet in the air. The entire project structured by actual cut steel fins that this distance is about 160 feet. That's about 120 foot cantilever. The fins are 5 feet at the elbow of the column and taper to about 2 feet at the edges and where they meet down this spine. We have to somehow work through this with the architect and generate for the owner an understanding that we're not completely insane and that it can be built. Recently, after going through a bunch of design assist work with the steel fabricator, who's from Italy and amazing, we realized that we had spent a little too much time as an entire team turning everything on the project into steel because it was easy. And we had ballooned from about 1,500 tons to 4,000 tons of steel, freaking everyone out, including us. Although we tracked that along the way, I think the impact was not understood by everyone because we kept figuring the steel replaced some other material, but not to the degree it actually did. We were able as a team, led by our firm in the last 3 weeks, and through this round-tripping process and fat pens and trace paper, to reduce the steel back down to about 2,000 tons. Which the client is getting their head around as reasonable upping from SD rather than the 2,500 ton increase that we had found. But generating these diagrams is only possible these days. There is no way you do these 2 or 3 years ago where we get a Rhino model from the architect and within a day are able to produce a basic working SAP model to reality check the behavior of the frame. But how do we tell that to the owner? The owner has engineers on board. They think we're all insane. They want to understand where the load paths are. And so we've come up with a series of our sort of version of fat pen sketches to go back to the owner and explain where the general forces are, talk to them about how the building is working. More importantly, these diagrams are what I'm talking about. When you're lost in these models, you have to be able to demonstrate the basic workings of the building. One thing we got to early on that still is causing a little consternation, but we are very sure is the right way to go, is the idea that the cantilevered top portion is a tabletop that is pinned at the column. We were finding early on that the cantilevers way out the end were punishing the columns. And so what we discovered was that if we released the frame and let the back arm act as a big tabletop on 3 pins, the columns could be actually much more efficient. More importantly, when we did that, the reactions at the base became much more consistent. They were just 3 big flagpoles with the same amount of load, and every time we tweaked a fin, we didn't impact the moment at the base. Why is that important? Because the foundations are going in the ground months before the steel design is done. So understanding these basic principles allow us to both speak to the architect and the client and have that collaboration in a way that doesn't alienate the client or piss them off that we're trying to hold things from them. It allows the architect to design in a way where they really understand where they're trying to put their effort. It allows us some freedom to then design within these constructs. More importantly, it allows us to reality check our own models. And finally, high up in this organization were a bunch of people that came from the oil rig business who basically want to know why this thing didn't just weigh 12 pounds per square foot and why the hell anyone would do this. And for them, they had their other peer bosses who said they wanted the 3 columns. So for them, we put together a study that basically showed that Silman can design 12 PSF buildings. If you give us a nice grid and you're 12 foot tall and you put some cross bracing in, we get a 12 PSF building. If you put 400 pounds per square foot of landscape on top of that building, the tonnage increases. If you then elevate it 40 to 50 feet in the air, it increases further. And if you remove all but 3 columns, it increases further. So this diagram was shown to the executives about a year ago, and they gave us the freedom to design a 55.5 pounds per square foot steel structure because they cross-checked that against costs of faking in the steel that would have been a ceiling under our structure. It's this kind of communication that we've gotten incredibly sort of, we spend more time figuring out how to make these diagrams than bragging about the thousands of pages of calculation that SAP spits out. And so I want to end where I began, sort of, with my own firm's mission statement. It's simple and does not include anything about making money, which pisses off some of my partners. And it is simply joy with meaning. That's our mission statement. Why joy? And how does that connect with language or communication or collaboration? Because all of this language learning, communication, collaboration, failure followed by success, and sometimes more failure, iteration, and searching is really, really difficult if not fueled by joy. If I bring you anything concrete this evening, it is that I've confirmed a simple truth over the years. All of what I've shown you was fueled by joy. Joy that I got to participate in creating things that change lives and inhabit the landscape for years to come. Joy that does not come from other professions. Our profession is messy. It is difficult. But in the end, if you're lucky enough to see your designs built, it is joyous. And joy begets creativity, which begets collaboration, which begets learning, which begets, of course, more joy. Joy is to happiness as language is to communication. Joy and language are deeper, ever present, and ever evolving. Thank you. I went a little over, I apologize.
Well, I want to thank our speaker and open the floor to any questions
Please.
that you may have. And I think I'll turn some of the lights on so we can see each other a little better.
Somebody break the spell. It's always the brave first one. Yes.
We were talking upstairs, and I was sort of telling you about what's going on in comprehensive and things, and so I just wanted to know if you had any experience in the academic setting, or in terms of like how students, especially maybe early on, can start to develop those collaborative behaviors.
Yeah, I actually taught for about 15 years, up until about 2 years ago. I taught the integrated studio at Princeton with Paul Lewis. And I've taught at Columbia in the integrated studio, and my visiting down to Rice every fall is in their totalization studio. So I've spent a lot of time in these studios. For me, I think what I challenge students when I'm on these crits and when I'm talking about projects, it's to really challenge them to own the design and own, and some of you are on the engineering track, but as architects, to own your role as the prime consultant, to own your role as that leader of the band. And so I will often challenge this sort of, sloughing off of the design you want to the engineer. To say, well, I put this curve in here because it's more efficient. I built this spline because it's like a shell when it has nothing to do with a shell. I took this column out because I thought it would be better, for the landscape, or I wanted to bound. Own your design. And then work with the engineers or work with your professors to what you want to get out of that design. And that's what I really try to get at, I think, both in practice and academia, is that conversation going where it's really about, what do you want here? Not what do you think I want, not what do you think you should do, what do you want out of this project? And then often you'll find that things cascade from there in really wonderful ways. And there are, Grace Farms, it's a cliche, but it goes without saying, almost every project I look at starts with very few columns. Or it starts with a Varendale truss. And Varendale trusses are the most horribly inefficient thing on the face of the earth, but architecture students love Varendale trusses because they give you this wide open space. So we did Milstein Hall with OMA at Cornell, which is this sort of hybrid truss that's half Varendale, half standard truss. And it basically, the story there was that OMA wanted a Verandale, but it was such a massive series of columns that were so closely together, it was like being in some little Mary Miss sculpture where you had like little peak holes between the 36-inch columns. And they could not live with any sort of, Bridges of Madison County truss that just sort of went through the space. So we spent 3 or 4 weeks with them, and the trusses that inhabit the architecture school at Cornell are these wacky sort of half diagonal, half vertical trusses that are a little more diagonal at the highest moment zones and a little more vertical at the least. And they give you something, and Cornell was happy because they didn't cost the $4 million that the Verandale cost, and OMA was happy because they cost a little more than the $1.5 million the standard truss cost. Everyone was happy. But I think it was owning that idea of what it was they wanted. Not that they wanted a Verandale, they just didn't want a standard truss that unlocked the design. Yeah.
Where do you see a lot of interdisciplinary careers kind of bumping heads with each other? Like, does that happen all the time? Where does it occur?
Yeah, I'm not sure exactly which type you're thinking of. What I will say, I was just talking to some younger partners in the office the other day. What I'm seeing, what's amazing and wonderful and sort of exhilarating in many ways, many of the younger firms that we now work with are graphic designer, landscape architect, sculptor, architect. It's this, and I don't know if that's what you're getting at, but at least in the New York City area, and while we're working nationally now, many of the smaller firms we work with are local to our offices. They are built in a totally different way. And so that collaboration has in many ways been incredibly inspirational and wonderful to sort of come to the table not just with a singular idea or vision, but with a group vision, and having to immerse yourself in that and not just being beholden with the rest of the people to a singular vision, but being sort of the interloper to a group discussion has sharpened our, the way we think about this even more. In addition, many of these firms are building out their own spaces, a la Gluck Plus. So it is hard, in a wonderful way, to simply say to them, that's what it has to be, because they'll come back the next day and say, we built it in the shop, and it's a lot stronger than you said. So you have to model these things and think about it and give them better understanding of why you're saying it makes sense to go in this direction, not simply, please, just use a steel beam there, it'll be a lot easier. I don't know, is that what you're getting at with interdisciplinary?
Yeah, sure.
Yeah.
So having been part of like other organizations and things like throughout high school and stuff like that, I've noticed that if someone is leading a project or a team towards a certain goal, sometimes there's people that don't always agree with whatever that like the trajectory of the project is going on. So if you're leading a project or you are that person that doesn't necessarily agree with that trajectory, how have you dealt with or proposed the idea to change it or keep the way that it was without sounding like Thomas Trick?
That's happened on occasion. There's been a couple of projects that go in that direction. There are projects where you end up with this sort of Frankenstein because no one can agree on what the right direction is. For the most part, we've been very fortunate. I mean, I think at this point in our career and our reputation, we get hired for this reason, which is nice. So it, again, sort of keeps the flywheel going. But to your point, I think that gets really to the heart. When I talk about this joy or this language, we're not always agreeing, far from it. But when you can find a common language with each other, and again, I think it was funny because I was playing with this idea of this lecture in my head for months, and I did sit down with my wife over 3 or 4 wines at the restaurant outside the Whitney, which is quite a good place to try to figure these things out. The wine is quite good. And at first I was like, I'll do a lecture on language, and like Stephen Hull will be Greek, and Renzo Piano will be Russian, and my wife looked at me and said, you're out of your mind, and you can't do that. You'll embarrass me and your family. But we started to talk about it, and I, she said, well, what is different? What do you do that's different? What is it that you're trying to get at? And that idea of the UN translator, which I sort of rushed through here, but that idea is really there, that you can listen very well to each other because there's somebody there. We can now understand all these languages. But the idea of how you speak it and discourse and deep debate about it is a whole different thing. And within that discourse, if you think about those examples and ideas, and I will bravely just sort of tickle the dragon for a second and speak on broader terms of our nation as a whole. When you can find an actual common language to have an actual conversation, which is what's behind almost all these successes, you can make those comments without being pompous, without being disregarded, without sounding, disrespectful of the idea. And you can be told back why that idea might not be the best in a way that brings you on board, doesn't beat you down, doesn't make you feel uninspired, doesn't make you feel unappreciated. That's the level of discourse we're talking about. So what I didn't get into, and it's not to, it is what goes into a lot of this, and what I tell people now that I'm, again, fortunate enough to be invited on the teams. One of the weirdest parts of being in this place right now, of having this success, is sort of being invited now onto projects of super grouping, where you get called and you're like, we heard you did this, this, and this, and we're going to combine you with this person and that person, and you guys will be amazing. Wait till you meet them. And you all get in a room and sort of stare at each other. One of the things that I have found, and it sounds silly, but many of these projects and ideas do come about over dinner and over drinks and over the course of 3 or 4 days of meetings. Piano's office flies everyone to Genoa for workshops, and it is a privilege and a really nice thing. They serve you lunch during the day. I mean, it is sweet. If you ever get invited to a workshop at Renzo Piano's building workshop, go to this workshop. It looks out over the Mediterranean. It's like the story I tell is about 15 years ago or 10 years ago, I went to my first one to do the Whitney. We were in schematic design. I had never drank coffee in my life, and every hour they stop and have a shot of espresso. When in Rome. So I did my shot of espresso every hour. I think I designed the entire Whitney that afternoon. I was like, okay, I got the whole thing. It's all done. But a lot of the stuff did not come out during the day. Renzo's amazing to watch. I cannot explain how fortunate it is to be in that presence of Stephen Ola, Renzo, or any of these people. Renzo sat there during the Fog Museum with a piece of Mylar over a 3D model that his model shop had built, and he took charcoal, and he said to the owner, the energy emanates from the center. And he just drew this beautiful spiraling charcoal circle on Mylar floating over a 3D. And therefore, we must change the entire design. And the client said, okay, that sounds good. And his 2 associates went up to their drafting table, and in ink and colored pens over the course of lunch, redid 5 elevations in the most spectacular fashion, showed the client. They said, yes, we must change everything. And we did. So these things, those are the things that happen not in collaboration, but it was the dinner after. It was the morning after, because I got to know Mark Carroll, Renzo's partner, very well. We're very close friends now, where Mark would pick me up at 6 in the morning from the hotel and say, before everyone gets there, we should just go to the workshop. And half the time, we wouldn't even meet at the workshop. He would be on his computer. I'd sketch things. He'd come by. We'd talk about this move or that move. I'd sketch a little more. He'd sketch some. It's those moments that collaboration occurs. So I think the other trick is what we learn early on in life, right? Face. You do not bring up criticism of the design in front of 30 other people in the room. You bring it up in quiet moments. You question these things when you feel you have that ability and that opportunity. And then you build on it in a way that builds trust over time. Sana, frankly, I met with them once. I got to be honest. But their team was incredibly strong. The associate architect they had in New York was incredibly good, Handel Associates. They brought people from Sana who worked with Nizizawa and Sejima, and they were incredibly talented. They attract unbelievable talent. We worked with them very closely. But the moments on Sana's work was more like we came up with those 4 ideas, and then we spent 3 years refining the hell out of those ideas. And that was a lot of fun in its own right.
I think you're hitting on something that will ring true to our student body here, that mutual respect, dialogue, and collaboration are part of what we do here as a school. And I want to present you with our school pin.
Thank you.
And everyone, round of applause for Mr.
I've never gotten a pin, so thank you. That's great. My 10-year-old daughter wanted a hoodie, but now I can bring her back a pin and a hoodie, so that's good.